I think we're witnessing AI on AI violence here because this is reading like somebody looked at the code and then decided not reading 15,000 lines of Python and then decided to analyze it with AI to write this post. So HexStrike is some kind of like MCP server that serves up a whole bunch of different systems for using with language models. And this interface is just atrocious. You're going to embed something, but you're going to choose the absolute worst interface possible. Let's see. This is garbage right here. All right. So a couple of things. It's got some kind of intelligent design decision for tool selection, parameter optimization, and attack chain discovery. And then over here also, there's some kind of a bug bounty agent, CTF solver, a couple of different autonomous agents that it's working with. So it's got a couple of interesting ideas here in it, a bunch of different tools. I've been digging through the code a bit. I thought about maybe spinning it up to test out, because if we can look at the server here, in fact, first thing I want to look at is this has AI code written all over it. So it's very interesting, and I'm curious if it even works. I'm not saying AI generated code can't work. I'm saying you got to finesse it a lot and really work on it. And the reason I say that is because this is it. This is the code. There's 3 Python scripts in here. It's not modularized at all. It's just one big fat chunkin script in here. So going through and looking at it, I was like, what are they even doing with this? Let me see if they even give an example of running this thing. They give an example of running the MCP server. Let's see what the MCP server is actually doing. And I'll tell you why we're looking at this really in just a second. Let's see. Let's clap some of this stuff down. So they're importing this stuff here. Is this really all the imports? So what are they doing with the MCP server? Because they have a server in here. There's also an MCP server, and there's an AI MCP. I was like, what is the difference between these? Let's see, what are they doing in here? Using a little bit of Selenium. You're supposed to have a browser configured for it to run. But this is the thing I was talking about. Look at this. Look at this absolutely chunking thing. It's 15,000 lines in one file in here. I was like, what is this hot garbage? How big is the MCP server? We see. Was this the one I was just looking at? Let's see. This one's 5,000 lines. I was like, it's all just in one giant file. And this right here is what makes me a little bit suspicious about it, because when you see stuff like this, every time I have generated code from something like Claude or OpenAI, they just have such a hard on for the emojis in here. It's always this. I'm not saying it's a bad thing. I'm saying it's a telltale giveaway. Why am I talking about this Hex AI system in here? Well, it's because Checkpoint just actually released this notification saying they are suspecting it was used as part of exploiting some Citrix ODAs. A couple of the key findings from this. From Checkpoint, HexStrike AI, when language models meet zero-day exploitation. So a newly released framework called HexStrike provides threat actors with an orchestration brain that can direct more than 150 specialized AI agents to autonomously scan, exploit, and persist inside targets. They're using this term, but actually whenever I looked at the code, I didn't see any framework libraries. Let's see, within hours of they're talking about HexStrike's release, dark web chatter showed threat actors attempting to use HexStrike to go after recent zero-day CVEs, with attackers dropping web shells for unauthorized remote code execution. These vulnerabilities are complex and require advanced skills to exploit. Really? It's got a CVE, dude. Threat actors claim to reduce the exploitation time from days to under 10 minutes. Okay, I'm very curious about this. Let's check it out. Let's see. So a recent Executive Insight blog examined the idea of a brain behind next generation cyber attacks. Next generation. There's one for your buzzword bingo. An orchestration and abstraction layer coordinating large numbers of specialized agents to launch complex operations at scale. The architecture was already beginning to appear in offensive campaigns, signaling a shift on how threat actors organize and execute attacks. So the emergence of HexStrike AI now provides the clearest embodiment of the model to date. The tool is designed to be a defender-oriented framework, quoted as a revolutionary AI-powered offensive security framework that combines professional security tools with autonomous AI agents to deliver comprehensive security testing capabilities. Now, what's funny is the professional security tools they're mentioning here. We come back over to HexStrike. Yeah, their professional security tools are Nmap, Matscan, Harvester, Responder, NetExec, Buff, WordPress Scan, Medusa, Ghidra. Now, Ghidra is actually pretty cool, but still, I was like, how are you even orchestrating this stuff with this and having having the ability to say these are professional security tools. These are just off-the-shelf security tools. Immediately after release, malicious actors began discussing how to weaponize it. So within hours, certain underground channels discussed applications of the framework to exploit a Citrix NetScaler ADC Gateway 0-day, disclosed on Tuesday. In this case, it was on the 26th. So this marks a pivotal moment. A tool designed to strengthen defense has been claimed to be rapidly repurposed into an engine for exploitation. Really? Really? This hasn't ever happened before? Was the article written by AI? We're going to take bets on it here. But here's a couple of screenshots like, oh yeah, so people are talking about a new tool that got dropped. Yeah. But this is the only screenshots that I saw of it. So it says HexStrike is not just another red team framework. It represents a fundamental shift in how cyber security operations can be conducted. At its heart, it's an abstraction and orchestration layer that allows AI models like Claude, ChatGPT, and Copilot to autonomously run security tools without human micromanagement. More specifically, HexStrike introduces MCP agents, an advanced server that bridges. You're going to call that an advanced server? It's 5,000 lines in one. Never mind. With real-world offensive capabilities. Through this integration, AI agents can autonomously run 150 cybersecurity tools spanning penetration testing, vulnerability discovery, bug bounties, and security research. So the AI orchestration brain interprets the operator's intent. The agents perform specific actions like scanning, exploitation, deploying persistence, or exfiltrating data. The abstraction layer translates vague commands like exploit NetScaler into precise sequential technical steps that align with the targeted environment. I'd be really interested to see what they're doing. So this mirrors exactly the concept described in our recent blog, an orchestration brain that removes friction, decides which tools to deploy, and adapts dynamically in real time. We analyzed the source code and architecture of HexStrike and revealed several important aspects to the design. The framework sets up a fast MCP server that acts as a communication hub between a large language model and the tooling. Tools are wrapped with MCP decorators, exposing them to as callable components the AI agents can invoke. This is the orchestration at its core. It binds the AI agents to the underlying security tools so commands can be issued programmatically. HexStrike also incorporates core network discovery and exploitation tools, beginning with Nmap scanning and extending to dozens of other recon and exploitation and persistence modules. Each tool is abstracted into standardized functions, making the orchestration seamless. The client includes retry logic and recovery handling to keep operations stable and even under failure conditions. So this ensures operations continue reliably, a critical feature when chaining exploits and persistence attempts. There's also, what is this? Intent to execution translation. High-level commands are abstracted into workflows. The execute command function demonstrates this here. An agent provides only a command string, and HexStrike determines how to execute it, turning it into a precise, repeatable tool action. That's, interesting. I'm curious how this function definition alone, without any of the accompanying code, does any of this. I think we're witnessing AI on AI violence here, because this is reading like somebody looked at the code and then decided, same thing I decided, screw that, I'm not reading 15,000 lines of Python that have no organization to them and are just dumped into one file, and then decided to analyze it with AI and then use another AI to write this post. Because how are you getting any of this from a function definition? Anyway. Why does this matter now? The release of HexStrike would be concerning in any context because its design makes it extremely attractive to attackers, but its impact is amplified by timing. So on Tuesday, Citrix disclosed 3 zero-day vulnerabilities affecting NetScaler ADC and NetScaler gateway appliances as follows. So there was an unauthenticated RCE, God, I can't talk, already being exploited in the wild with web shells observed on compromised appliances. There was a memory handling flaw impacting NetScaler's core processes. Exploitation was not yet confirmed though. And there was an access control weakness on management interfaces, also unconfirmed in the wild but exposes critical control paths. Exploiting these vulnerabilities is non-trivial. Attackers must understand memory operations, authentication bypasses, and peculiarities of NetScaler's architecture. So such work has historically required highly skilled operators and weeks of development. So with HexStrike, that barrier has collapsed. In underground forums over the 12 hours following the disclosure of the vulnerability, we've observed threat actors discussing the use of HexStrike to scan for and exploit vulnerable NetScaler instances. So instead of painstaking manual development, AI can now automate reconnaissance, assist with exploit crafting, and facilitate payload delivery. All right, let's see if we can zoom in on this. Of course, this crap is in Russian. Looks like they provided a translation, thank God. Let's see. So he says, I was able to play around with the latest nulls in Citrix right away. I wrote working proof of concepts, but I got tired selecting scripts every time. I decided to automate them. I uploaded the whole process to a custom module for Hex AI. It turned out great. So, hold on, let me finish this before I start going off on anything. So you throw in a list of targets and it does everything else itself. Finds, checks, and if the target is suitable, it takes it. So the shell comes back stable. Watching how everything works without my participation is just a song. I'm no longer a coder worker, but an operator. The tool turned out to be powerful. Let's go back a bit. In underground forums, over the 12 hours following the disclosure of the vulnerabilities, we observed threat actors discussing it to scan and exploit NetScaler instances. Now, what's telling here is they're writing this like, oh, HexStrike did everything, and it just has a magic I win button, right? Instead, what's the guy actually say? He says, I wrote the proof of concept. I got it to where it was stable, and then I just gave it to the AI system. How is this any different from Metasploit? Don't get me wrong, I think it's interesting, yes, because there's some more automation to it, but they're making this sound like HexStrike is the reason why the vulnerability disclosure went to proof of concept practically overnight. Like, it accelerated that. I was like, no, this guy already had it in here. Oh, geez. All right, certain threat actors also publish vulnerable instances that have been able to scan using the tool, which are now being offered for sale. Again, there's a thing in Metasploit where you can craft your exploit, and there's a check command in there where you could go check this. So I still find this very interesting that this is the route they're going, but at the same time, it's not earth-shattering. This isn't Skynet waiting to be born. I love this. The implications are profound. A task that might take a human operator days or weeks can now be initiated in under 10 minutes. Really? It takes days or weeks to go write a damn script? That's it? It takes days or weeks? Exploitation can be parallelized at scale with agents scanning thousands of IP simultaneously. So can mass scan and every other scanning tool, or Nmap if you just go write an NSE script. Decision making becomes adaptive. Failed exploit attempts can be automatically retried with variations until successful. The window between disclosure and mass exploitation shrinks dramatically. Okay, good job, Checkpoint. And then they've got some action items for defenders in here, which of course kind of plugs their own stuff. But dude, this is bunk. I kind of want to go look at this real quick, because now after reading this and kind of seeing some of the bogusness with it, let's go look at HexStrike again. Let's see if we can dig into this god-awful display here. This dude. Can I zoom in on it? Can I move it? This is absolute hot garbage, is what this is. I gotta click every damn time. All right, so we have some kind of AI agent, and that's going down to the HexStrike MCP server. Actually, let's go look at some of these agents in here. So for example, let's go look at this intelligent decision engine. Let's see if we can find that down in the code. So this would have to be in the server, not in the MCP. Let's see, decision engine. Let's see if we can find this. All right, so here's the intelligent decision engine. So we've got a class where we're talking about a target, potential technology stack. Yeah, this was 100% written by AI, because look at this. Why would the technology stack, why would it be so set in stone? Because there's no adaptability to this. I can think of plenty of systems that are not using Apache or Nginx or IIS or Node. I mean, this is not an exhaustive list. There's other technology stacks outside of web, right? Let's see, target profile. What do they got here? IP address, open port services, tech, security headers, SSL info, domains. Dude, I think, Chris, whenever there's stuff that I understand very well and people are fear-mongering over it, it just kind of gets on my nerves. What about this attack chain? Let's see. So what are we doing with this attack chain class? So we add a step to it. Required tools, estimated time, calculate success probability. Where does this actually even get called? It gets called another 1,000 lines down. Okay, so we call chain.calculate success probability. Use compound probability for sequential steps. Okay, so we got a probability. Basically, if we don't have any steps, then the probability is 0 and just returns. Probability of 1. So if we're steps in the steps, the probability times the success probability. I wonder where they're even getting this success probability. At least that doesn't look horrible. But I mean, there's some exploits. This even seems kind of weird though, because there's some exploits, they have many, many steps in them, but they're very reliable. You can just fire them out. It's no problem. Here's the actual intelligent decision engine. Let's take a look at this. So what do we got here? Let's see. So initialize tool effectiveness ratings for different target types. And see, this is kind of odd. Like, hey, why are these hard-coded values in here? High for WordPress sites. Only if you're going to find something that's in one of the plugins. WordPress itself usually doesn't have very many vulnerabilities. All right, so these target types are interesting. Then what would it do? Initialize technology signatures. All right, so we're just returning a whole bunch of data in here. It's stuff like this. This is what makes me think that this is completely AI written, is because stuff like this data, this should probably be busted out into a different section. Like this should be in a maintainable section, not something where you've got to go scroll down several hundred lines to go pick it out. But anyway, so common attack patterns. Let's see, nmap, and then HTTPX, Katana, Gao, wayback URLs, nuclei, dir search, dir GoBuster, right? API testing, network discovery, ARP scan. Yeah, you've probably been using that a whole bunch. Let's see, phone assessment, using Nikto. That's ballsy. I haven't seen anybody use Nikto in a long time. When was the last time Nikto was even updated? Hang on. I'm actually surprised at this. I thought Nikto was a dead project. I've not seen anybody use Nikto in a long time. Let's see, binary exploitation, CheckSec, Hydra, Proper, One Gadget Pwn tools. Let's see. Okay, so after we get through all of this stuff, analyze the target. Let's see. So they get a target profile of whatever the target is. Type is whatever comes back from the target. Basic network analysis, technology stack detection. And then what does this calculate attack surface score? You know what's funny is with everything that's kind of hard coded into this, I really want to spin this up and test it out, because I feel like there's ways to actually be evasive on this thing and it not know what the heck is going on. Because like, for example, here, if it's a binary pattern, okay, yeah, cool. It's a binary file. If it has any of these endings to it, what if it's a Linux system? Linux systems don't have to have any file extension, or can have whatever file extension they want. Let's see, calculate the attack surface. These values are so arbitrary. This is so weird. I mean, I know it's AI slop. The question is it AI slop that even works? I'd be very curious about this. I tell you what, let me hop down to the main function. Let's just go all the way down to line 15,000 of this monstrosity. Right, let me see something here. Cyber Orange, love this. Okay, so you spin up. Let's go look at the MCP server, because I want to see what this is doing. Because right now, I'm not seeing anything agentic about this. Over here in the MCP server, let's see what's actually being exposed here. Our HexStrike colors. Let's see what else we got here. Get rid of the color formatter. Some logging basics. Actually, hold on. Before we even get down to this, let's go down to line 5,000 of this other monstrosity and check out the main function. Let's see. So it's going to parse some args. What are we going to do? So we're going to initialize the HexStrike client with an arg and a timeout. Okay, so let me see what they're doing with this guy. So they're initializing an HexStrike client, and then from the client, they're setting up the MCP server. So let's go look at this HexStrike client here. Why would you do that? I don't want this. Wait. Where's the HexStrike client? There it is. All right. So when this thing initializes, we get some kind of a server timeout session, some max retries here, a safe get, safe post. So these are the functions for it to talk to the API on the back end. So we got to execute command, set up our MCP server. Okay, so here's where they're using the MCP tool decorator in here. So for the in-map scan, you see that? Looks like they're just keeping the... So they're essentially doing... Hold on, before I pass judgment on this, let's go take a look. But look at this, the scan type, we have a string, it's got a default in here. So I'm not gonna pass judgment on it just yet, because it could be that this function is getting called with something else in here, whatever the scan type is. Ports, additional args, and it's gonna return a dictionary. Okay, let's see what else we've got in here. Where's it actually launch this? Okay, so it launches it from the MCP server, from, they call safe post, over to the tool in map. They pass in whatever this data structure is here. So hold on, let me duplicate this so I can go look at the server. Because I'm very curious to know what they're doing over on the server side. Let's see. Here's the server. Let's see, so we have tool-specific parameter optimization. Okay. So where's our optimize in-map parameters? I'm just kind of walking through to see what it's doing in here. So these are their optimized parameters. They look to see what target type it is. If it's a web app, it scans common web ports. All right, cool. If it's a network host, it just scans the top 1,000. That's optimized. Okay. Cool. Cool story, bro. So after it gets this back, we check the results. We have a Go Buster scan. The thing is, I don't see anything in here that actually is agentic. And that's what I was getting at. Let me show you this real quick. When I looked at this earlier today, and I can look at the requirements.txt, this tells me all the Python libraries that are getting loaded in. So there's only two options if they're creating any sort of agent, like something that is actually executing a workflow or is autonomously executing some kind of thinking path. And that is, they've got to be importing something or they've got to be rolling their own. Well, they're not rolling their own. There's literally only two Python files in this entire thing. So if we come back over here, what are they importing? Flash, request, PS utils, fast MCP. None of this is related to agents. Beautiful soup, Selenium, WebDriver, not related to any kind of agentic framework. Let's see, async IO, nothing there. Man in the middle proxy, nothing there. Home tools, Anchor, that's it. There's nothing agentic about this. This is just a fancy souped up MCP server. That's what I was expecting. All right. Well, this is kind of interesting. Ultimately, this is kind of crap because it's completely non-modular, as far as I can tell. There's no way to go through, let's say we wanted to go add our own tool to this, like something like we would do with robo pages on Hackbot. We can't go write a new YAML and plug it in here. You're going through and you're going to be modifying this and inserting it in 100 different places, working this code, trying to decode this 5,000 line server and this 15,000 line MCP server. This is a child's toy. Did y'all hear about the talk from DEF CON? It got pulled and it was accepted and given at DEF CON, and then they pulled it because it was all hallucinated AI slop. Did you guys hear about that? And yeah, Panda, I watch John Hammond whenever I can check out his videos. I don't have a ton of free time, but yeah, when I can, I go check him out. I got to meet him one time at Black Hat. Let's see. So we can find it. DEF CON talk, pull for AI slop. Where was it? Let's see if it's still up here, because the guy like just got rid of everything, I think. Let's see, is this still up? Yeah. So this VM Dragon Slayer, comprehensive framework for analyzing binaries protected by virtual machines. And everybody was actually really excited about this. And then a couple of guys went to it and they looked at it and they're like, some of this stuff doesn't make sense, but okay, maybe he's found some novel way to do that. And it just turned out that it was complete AI BS that never even worked. So again, this is where I like to caution everybody. Yeah, I'm working on Hackbot using AI stuff, but also I'm building it. I'm not having an AI write it and then saying, hey guys, this is the greatest thing in the world, is going to fall down and we're just going to lose everything and red teaming is done and the time to attack things is diminishing. This article, this Checkpoint article, this is AI on AI violence. That's what this is. Because this doesn't look like it was written by anybody with a solid understanding of security and what they were looking at and what they were even reading and comprehending against a tool that was written by AI that is just an MCP server with 0 agents to it. And hold on, I got to look at one more thing. Let me look in this server here. So let me find all the references to Nmap in here. There's our optimized Nmap parameters. I want to know where it's actually executing Nmap from. Because I'm willing to bet you dollars to donuts it's running the local copy of Nmap from the machine. God, this thing is so chunky, it's choking GitHub's interface. Execute Nmap scan. Okay, so here, let's see if we can get this. So the command parts, port additional, and it's going to return an execute command. All right, where's execute command get defined at? We follow this. This executes a shell with enhanced features. So the executor is enhanced command executor. Okay, so what's an enhanced command executor? Let's see. Read standard out, read standard error, show progress, execute. All right, finally, let's see. So we're going to load some threading up. So yeah, literally what they're doing is they're just running the thread from a local copy of this thing. So yeah, you get access to all these tools if you've got them installed. I really want to like AI, but everybody and all of its interesting implications needs to realize that large language models right now are toys. They are toys. You should not be giving them any decision-making power whatsoever. And this is also coming from somebody who recently was doing an offensive security assessment against a computer agent, and were able to get it to do some pretty wild and outlandish things without a ton of effort. This is going to be really cool stuff in the future. Right now, it's a toy. The toy is not going to take your job. Everybody who is betting on it, replacing people where they work, their employees, they're going to learn a very hard lesson very quickly. I dare say, if someone finds one of those unicorn developers who's actually a very good mentor, a senior developer, somebody with decades of experience who is good at mentoring people, and if you get that person, not even necessarily for coding, for anything that's being hit by the AI slop tsunami, and you take a group of people who are dedicated to learn, that are fresh junior prospects, and you pair them together, in 5 years, you will have a team that all of this AI stuff is going to play. I really do feel that way, because it cannot come up with anything original. It's coming up with stuff that is interesting, stuff that's kind of neat, but you end up with stuff like this. 15,000 lines of Python in one file. Yeah. People who are losing their jobs, I hope you ask for double your salary when you get asked back, because they're going to need you back. Yeah, so this is nuts.